Bismillahirrahmanirrahim. Allahumma rabbi zidni ilma. Bismillahirrahmanirrahim. Assalamu alaikum. Welcome dear students in the subject of Internet Architecture and Protocols. It's Ghulam Yasin, lecturer in Computer Science, University of Education Lahore, at DG Khan campus. Dear students, our today's lecture topic is bridging and switching. Basically, a bridge performs different functions and switch also performs different functions. So this concept is called bridging and switching. There are some contents which we will cover inshallah in our coming two lectures as well as today's lecture. To understand the function or functioning of layer 2 devices, what is broadcast domain, what is collision domains, differentiating between a bridge and a switch, to understand different bridging and switching techniques, to examine the different types of bridges and switches. Overview of link layer or overview of data link layer. These are some main functions of data link layer. Number one, data flow control. What is flow control? Dear students, sender and receiver has some limited capacity to receive or to transmit data. If more than the data of the capacity will be transmitted towards receiver, then there will be overflow and there are chances of data losses. So there must be flow control, and data flow control is main responsibility of data link layer. What is error control? What is error? Change of data is called error. If the user has transmitted 0, 1 and the receiver will receive 1, 0, this is an error. So this must be controlled, and this is main functionality of data link layer. What is physical addressing? Physical addressing is of LAN card addressing, and this is also called media access control address, MAC address, and physical addressing scheme is deployed over data link layer. Managing access to physical media, because data link layer is connected to physical layer and data is transmitted with the help of physical layer in the form of signals. Next is framing. Data is transmitted in the form of frames on data link layer. And the last is example of link layer protocols, token ring and Ethernet and FTDI. What is a token ring? This is a complete technology as well, which is being used in a token ring topology. When the data is transmitted from one device to another device, this is shown in the shape of a ring, and data will be transmitted in the shape of ring, and all the devices will see the data, but only that device will accept the data whose address is mentioned in packet. And after receiving the data, original data and token will be transmitted towards sender, and sender will discard the data as well as release the token, and after that next device can transmit the data. So this is basically a token ring topology which has been studied by you in basic networking course. Ethernet, this is most common protocol for local area network data transmission. FTDI for fiber distribution data interface, this is again protocol in Ethernet or in LAN for data transmission. And 802.5, 802.3, these are different decimal numbers, you can say, which are assigned for these protocols, and these are IEEE standards. Because IEEE has developed these protocols, that's why these specific numbers are being used by IEEE to identify. So these are basic data link layer functions or duties or responsibilities. Inter-networking devices. Dear students, you can see the three layers of OSI reference model over here: physical layer, data link layer, and network layer. And there are some devices which are shown on these three different layers. First of all is physical layer, and you can see two devices over here: hub or repeater. What is hub? This is very simple inter-networking device. When we create a small network of 4 devices or 3 devices or 5 devices, so the hub is used. And there are some characteristics of hub. Hub is a broadcasting device. Hub can't contain any kind of addresses for data transmission, so that's why this is called an unintelligent device. Second is repeater. When the data is transmitted from one side to another side in the form of signals, after some time, after some distance, the signals will be going weaker and weaker. So repeater is used to boost the signal strength. So repeater is a device which is used to enhance the digital signal strength. Next, data link layer, and you can see two devices over here: bridge or layer 2 switch. Layer 2 switch is commonly switch which is used in local area network. If we want to connect more than 5 devices, more than 6 devices, then this switch is being commonly used in star topology. And 24 ports or 48 ports switches are available, by which we can attach 24 or 48 different devices. And switch is intelligent device. Switch contains MAC addresses of all the connected devices, and switch is a unicasting device. What is bridge? Bridge is basically used to connect two different networks. Let's suppose if there is a network in which we are going to use star topology and another network which is being used bus topology or any other topology, so then we use bridge to connect these two different networks. Next is network layer, and you can see router or layer 3 switch. Router is most commonly used device in wide area network. Router contains a routing table, and routing table contains entries of IP addresses. The router is also a security purpose device as well. And layer 3 switches are used in ATM network, asynchronous transfer mode, which is WAN technology. So ATM switches are also called layer 3 switches. So these different devices deployed at different layers of OSI reference model, and these devices are called inter-networking devices for data transmission in local area network as well as wide area network. Network domains. A domain is referred to a specific area. In our daily life, we use the word domain. So domain is a specific area or specific range. So in networks, those computers which come in a single domain, for example department, can by default communicate with each other. Let's suppose if we create a local area network of 40 computers, and there are 4 different departments. Let's suppose HR department, finance department, admission department, and examination department. So 10 computers belong to every department, and in this way network administrator will segregate a specific department under a single domain. So this is concept of domain or network domain in a specific networking concept. What is broadcast domain? First of all, we have to discuss about broadcasting, and broadcasting means communication to all computers, communication to all. So a range in which if a broadcast is done, all hear it. Just we have said that if there is a finance department and there are 10 computers in that department, means there are 10 employees working in that department, all the communication among those employees will be heard by all the devices if there is a broadcast domain or if the message is broadcasted. Second point, a group of devices in the network that receives one another broadcast message. So if the system falls in a single domain, then all the systems including that system will hear the message from any specific device because the broadcast domain is one. Last point, a broadcast domain is a set of network interface cards for which a broadcast frame sent by one NIC is received by all other NIC in the same broadcast domain. In local area network, MAC addresses are very important, physical addresses are very important. So the physical address or MAC address is of NIC. So network interface cards address is called MAC address or physical address, and if the system falls in specific domain and the message is broadcasted, then all the systems in that domain will hear that message. So this is basically the concept of network domains. In our network, we create a different type of subnetworks, and these subnetworks are called network domains, and all the messages in single domain are broadcasted and all the system in that domain will hear that message which has been broadcasted. Next is collision domain. First of all, you must understand what is collision. Collision in any specific network is a term which is used to collide different messages. Bus topology is very good example to understand the collision. When we use the concept of bus topology, all the systems are attached to a single medium which is basically coaxial cable, and all the systems transmit data without any centralized device. Because if we talk about star topology, there is a centralized device which may be hub or which may be switch. So this is a controlling device, and there are different mechanisms by which we can control the collision in star topology. But if we use the concept of bus topology and there is no any specific method to control the collision, then the data will be collide, because if system 1 will transmit data towards system 4 and system 6 will send data towards system 2 in opposite direction, and if there is no any control mechanism, if there is no CSMA CD or CSMA CA, these are different mechanism, different protocols to control the collision, then the data will be collide. So collision in any specific network is a problem. So over here again, this is collision domain, like we have discussed about network domain in our previous slide. So what is collision domain? A collision domain is a set of network interface cards for which a frame sent by one NIC could result in a collision with a frame sent by any other NIC in the same collision domain. So if there is a one collision domain, then the data will be collide. So collision domains must be more than one so that data collision can be controlled. Group of devices connected to the same physical media such that if two devices access the media at the same time, the result is the collision of two signals. Just I have discussed about the concept of bus topology, where two devices transmit the data at the same time, then the collision will occur. But if we apply the concept of a different protocol, which is a CSMA CD, carrier sense multiple access with collision detection, and carrier sense multiple access with collision avoidance, then the collision can be controlled in the bus topology. So collision domain means if there is a single collision domain and multiple devices access the physical medium at the same time, then the data will be collide and the data will be lost, signal will be collide, and ultimately data will be lost. Network domains. Any device with more broadcast domain is better, as it can segment the network into multiple network segments, reducing the broadcast and thus improving the efficiency in terms of time and load. If there are multiple domains, there are multiple subnetworks, there are multiple segments or network segments, then we can control the concept of broadcasting, because broadcasting is not good in network. There must be unicasting. So multiple network domains control the problem of broadcasting as well, if there is compulsory to send the message in the form of unicasting. But if we need to broadcast the message, then we use the concept of broadcasting as well. Two internetworking devices, a hub and switch, are commonly used in different networks, in different local area networks. So what is hub? Network becomes half duplex with hubs. What is the concept of a duplex? Normally we use the word simplex, half duplex, and full duplex. So in simplex, data transmission is towards one side. In half duplex, data transmission is towards both sides, but at the same time data transmission is not done towards both sides, either towards one side or other side. And in full duplex, data can be transmitted both sides simultaneously. Second point, hubs supports a single collision domain. Assume that at the back plane or motherboard there is a single route available for the frame to travel. So single collision domain means there is no any other path. If the data is transmitting towards one side and from the other side data appears, then the data will be collide. Switch. Network become full duplex with switches. So switches offers full duplex data transmission. At the same time, you can send and you can receive data. Switch supports multiple collision domains. Assume that at the backplane motherboard there are as many roads are available for the frame to travel as many devices are attached to the switch. So we can also take the example of a road. If there is a single road, this is example of half duplex. But if the road is double, there is one-way traffic, one side is for going and one side is for coming. So in this way, the chances of accidents are definitely zero. But in single road, the chances of accident of different vehicles are high, because both sides are used for the communication of that vehicles. So this is the concept of network domains in our networks. So dear students, in this diagram you can see four different devices: hub, bridge, switch and router. So hub is a broadcasting device. Hub is an unintelligent device. Hub works at data link layer of OSI reference model. Bridge, this is again a device which operates as data link layer. This is intelligent device. This is used to connect to different types of networks. Switch, this is intelligent device. Switch contains the addresses which are called MAC addresses or physical addresses or network interface card addresses. So switch is a unicasting device. Router is used in wide area network. This is a more intelligent device. Router contains a routing table and the addresses, IP addresses or logical addresses are kept by router. So collision domain, hub contains one collision domain, bridge 4, and likewise hub contains single broadcast domain and bridge also contains single broadcast domain. When we talk about collision domain regarding switch, there are four collision domains. Router, there are four collision domains. Switch, there is one broadcast domain, and router, there are four broadcast domains. So if the collision domains and broadcast domains are more than one, then there will be no chances of collision and broadcast network will be good. So router and switch, these two devices contains more collision domains and more broadcast domains, but the hub and bridge contains less collision domains and less broadcast domains. So these four internetworking devices are used to create collision domains and broadcast domains in networks. This is last slide of today's lecture. Bridges and switches. Bridges mostly used to connect to similar local area networks. Switches mostly used within a LAN in place of a hub in star topology. So nowadays switches are commonly used instead of hub because hub is an unintelligent device, switch is intelligent device because hub doesn't contain any kind of addresses and hub is a broadcasting device. Switch contains the MAC addresses, physical addresses, network interface cards addresses. That's why switch is a unicasting device. So in this lecture we have studied about switching and bridging and different features of a switch and bridge. We have also discussed broadcast domain and collision domain in detail. So dear students, thank you very much for your concentration, for your learning, for your passion. I hope best of luck for all of you always.